Welcome to the Vikrant. Myself, Dr. P. Chidrilingappa. Today we are going to discuss about network security under network security, cryptography, symmetric key algorithms, and public key algorithms with digital signatures. Network security. There are two important terminals are there. These two are seems to be very similar. One is the data security and network security. Data security protect data from the unauthorized user is called as the data security. Data security algorithms are the symmetric and asymmetric cipher techniques. Network security protect data during communication. Send data through the secure channel is known as network security. So how to protect the networks from the by using the digital signature and digital certificate to achieve the CIA goals and web security threats and key distribution through the secure channel during the transmission. Cryptography. Cryptography comes from the Greek word we can call it as a secret writing. A cipher is a character for character, bit for bit transformation without regarding to the linguistic structural message. In contrast, a code replaces one word with the another word or symbol. Majorly, these are used for the military purpose and diplomatic corps and dervishes, and these are the main purpose they are using at the beginning of the day. These are the some of the key terminals are there in this cryptography. Plain text is nothing but the original message. Encryption, the process of converting plain text into a cipher text, you can call it as the encryption. The process of converting plain text into cipher text, and the art of breaking ciphers known as the cryptanalysis. The art of devising them is collectively devising them is called as a cryptography. Collectively, we can call it as a cryptology. So, cryptography is nothing but the process of converting encryption to the decryption. We can call it as a cryptography. The reverse process, decryption to the encryption conversion, we can call it as a cryptanalysis. The both cryptography, cryptanalysis combined, we can call it as a cryptology. Plain text, the original text we can call it as a plain text. Now we can convert that plain text into ciphertext. So ciphertext is nothing but unreadable format. Encryption, the process of converting plain text into ciphertext, we can call it as a encryption. Decryption, the reverse process. The process of ciphertext is converted to plain text, we can call it as the decryption. And cryptography key. A cryptography key is a string of bits used by the cryptographic algorithm to transform plain text into ciphertext and vice versa. During the conversion of the plain text into ciphertext into plain text, without key we can't do this process. Cryptanalysis. Cryptanalysis, the method of transferring ciphertext back to the plain text without knowledge of the key. Code breaking is called as a cryptanalysis. Cryptography is nothing but the process of the combination of the cryptography and cryptanalysis called as cryptography. So, encryption methods. There are two encryption methods are there. One is the substitution cipher, transposition cipher. Substitution technique is one of the letters of the plain text are replaced by the other letters or numbers or symbols. So in this case what we are doing, so this is the plain text, this is the plain text, we can replace this plain text with the other letters like x, y, z. This is called as the substitution. And transposition is nothing but transposition cipher does not substitute one symbol for the another. Instead of it changes the location of the symbol. So in case of transposition, the same letters are going to be reordering like probability. That is called as the transposition. Some methods are there under the substitution, monoalphabetic and polyalphabetic are the some of the methods. And transposition is also there are some methods are there under transposition like so rail fencing and columnar transpositions are the some of the methods are there. In this case, what we are doing, Caesar cipher and Hill cipher, time pad and Playfair are the some of the examples. And Railfen cipher, columnar transposition cipher are the some of the examples. So, diffusion, confusion is a commonly carried out through the substitution. Diffuse is carried out by using the transposition. Ciphers in the cryptography. Basically, cryptography is used for transformation of plain text into ciphertext. There are basically two methods on which cryptographic algorithm will work. One is the stream cipher and block cipher. In the stream cipher, bit by bit is going to be converted, whereas in the block cipher, the block of bits are going to be converted into ciphertext. There are some fixed size blocks like 64, 128, 256 bits. Each and every block is going to be converted with the key size, with the different key size, 40 key, 56 key, 46 key. These are the some of the things. So stream cipher, key and algorithm applied on each binary digit. Key and algorithm applied for the block of data. Less time to consuming and it will take more time. Only bit by bit encryption is there, so it is faster than the block cipher. Block cipher is the block of data is encrypted at a time. Block cipher is the slower than compared with the stream cipher. It does not use for chaining mode and it is used for chaining mode. Hardware implementation is easy using the stream cipher. Software implementation is easy using the block cipher. One-time pad is the best example for the stream cipher. DS is the best example for the block cipher. Security in compared to the less security stream cipher, block cipher has the more security. Symmetric-key algorithm. Symmetric-key algorithm is an encryption method that uses one key to encrypt and then decrypt the data or message. Since is a secret or private key, the parties communicating using the symmetric and encryption algorithm must be securely exchange the key. Symmetric key algorithms are generally faster and more efficient than asymmetric key algorithms. So symmetric key encryption algorithms have the key length is 128 or 256 bits. Some of the symmetric algorithms are AES algorithm, DS algorithm, triple S algorithm, and RC4 algorithms. Generally, these are used to send the large amount of data, and the same key is used for encryption as well as the decryption purpose in the symmetric algorithms. So DES, data encryption standard. So DES follows the crystal structure. DES follows the crystal structure. DES is the symmetric cipher algorithm, uses the block cipher method for encryption and decryption. So this is the process of encryption to the decryption. So in this case, what we are doing, this entire process is going to be divided into some blocks, and we can apply the key for each and every block. So this is the plain text, 64-bit plain text, and we can convert into 64-bit to ciphertext at the each and every block. Like there are 16 rounds are there in this case. So this is the steps of the DES. The 64-bit plain text is going to be given to the initial permutation. The first 64-bit plain text is going to be converted into uh, given to the initial permutation. So after initial permutation, we can divide into two portions: left plain text and right plain text with the equal size, and each left and right plain text performed with the 16 rounds of encryption process. After that, the left and right of the plain text is going to be rejoined, and finally we will get the final permutation is combined block. Then the 64-bit plain text is going to be generated. 64-bit ciphertext is generated. Before that, we can apply the key discarding process. The key discarding process is nothing but 64-bit original key is going to be converted into 56 keys. So how it is possible? So by using this table, in this table we are using the 64 bits. At the last 8 bit of the each and every row is going to be discarded. Finally, we will get the 56-bit process. That is the first process, the key discarding process. Next, in the initial permutation is nothing but we can reorder the 64 bits of data and we will get the one more new data. Then we can divide the data into two, left plain text and right plain text, right, and okay. Then after that, 16 rounds of encryption, 16 rounds of encryption. First we can apply the key transformation, which means 64 bit is going to be, sorry, 56 bit key is going to be converted into 48 bit. And after that, we can use the key bit shifted for round, compression permutation, and expansion permutation of the plain text and apply the XR operation. Then you can apply the substitution, S box substitution, and then P box permutation. Then you can use the XR and swap, XR and swap, like that way. So key bit shifted for round is nothing but there are 16 rounds of transformation is there. Each and every round we can use key bits shifted. The only the first, second, 9 and 16 bits, and you can use only one round. You can shift only one round. So remaining you can use the two times. And expansion permutation. After expansion permutation, what we are doing, 32 bit right plain text is going to be expanded to the 48 bits. So how can we can expand? So there are 4 bits of data is there here. So there are 4 bits of data is there here, 32 bits, 8 blocks are there. Now we can convert these 4 bits into 6 bits. We can convert these 4 bits into 6 bits, like so 1 2 3 4, these are the 4 bits and we can convert into 6 bits. So you can keep 1 as 2, 2 as 3, 3 as 4 and 4 as 3. The last bit we can swap with the last bit of information, and so this bit is going to be swapped to the other second round. Then we will get the 48 bit of the right plain text. Then you can apply the XOR operation with the 48 bit key. The output is the S box substitution. Now S box substitution is applied and you can convert the 6 bit sub block into the again 4 bits output. Then you can apply this method. I will get this one. Then you can apply the P box permutation. The output of the S box is given to the P box. 32 bit is going to be permitted with the 16 to 2 permutation table. Then you can apply the XR and swap the two things. So this is the complete process. So 64 bit plain text, you can apply the initial permutation, then you convert into 32 bit left plain text and right plain text. And the right plain text, at the right plain text you can apply the key transformation, expansion permutation, S box and P box. Then you can apply XR with the left plain text with the whatever the outcome after P substitution. Then we can swap the data. So the right plain text is going to be swapped with the left plain text, and after XR whatever the value you will get, that can be treated as the right plain text. This is for first round. Like that you can apply the 16 rounds of information. You will get finally ciphertext, that is des, and you can apply the double des. Double des, very simple. Double des is nothing but you can apply encryption two times. So in this case, the plain text you can apply one encryption with the key 1 and you will get some ciphertext. This is an input for the next encryption process. So whatever the ciphertext we will get, again you can give that ciphertext as the input for the second encryption with the key 2. Then we will get the one more ciphertext. This is called as the double ciphertext. Triple DS is there. In this triple DS, what we are doing? So there is a original plain text. You can apply the, and you can do encryption by using the key 1. You will get one ciphertext. Again you can apply the encryption process with the key 2, and you will get one more ciphertext 2. Then again you can give the apply encryption process with the key 3, then you will get the final ciphertext. So in this case we are using the 3 keys, and you can implement the triple dash with the help of the 2 keys only. So instead of 3 keys, any one keys you can use, again repeat again. So I'm using the key 1 for one encryption and key 2 for one more encryption. For third encryption I'm using the same key. Whether you can use either key 1 or k2, that is triple dash with the 2 keys. So far we discussed about the DS algorithm. Somewhat it is a lengthy process. Somewhat it is, there are so many steps are there in the DS algorithm. The next algorithm is called as the advanced encryption standard. So, advanced encryption standard. So here what we are doing in this case, so AES works on the block cipher technique. Size of the plain text and ciphertext must be same. So an input key also required input to the AES algorithm, the same size of the plain text. So AES, in AES data length is different bits of information, 128 bit, 192 bit, 256 bits, supporting the three different key lengths, 128, 192, 256. AES consists of the multiple rounds of process, different key bits like 10 rounds for the 128 key bit, 12 rounds for the 192 key bits, 14 rounds for 256 keys. The first one is the plain text is going to be converted to matrix format. The plain text is going to be converted into matrix format. You can convert the plain text into matrix format, which is called as the state array. So after state array, you can apply the overall structure of the AES encryption process in the shown figure. The encryption of the each and every round consists of the 4 steps: substitution bytes, shift rows, mix columns, and add round key. So in the substitution or substitute bytes, so we can convert hexadecimal format. The whatever the input plain text is there, that is going to be converted into hexadecimal format. That is going to be converted into state matrix. AES defines 16 by 16 matrix byte values called as the S box that contains the permutation of all the possible 256 8-bit values. Each individual byte of the state is going to be mapped into new byte in the following way. The left 4 bits of the byte are used as the row. The left 4 bits are used as the row. The right one we can call it as a column. The row, these row and column values services as the indexes into the S box to select the unique 8-bit output value. So example, hexadecimal values of EA refers to the row E and column A of the S box. It contains the value 84. Accordingly, the value EA is going to be mapped into 84, 87, like this, 87. So here E and mapped with the EA. For that, the corresponding value is 87. Sorry, the corresponding value is 87. So like that, you can convert the state matrix array into substitution byte matrix. Shift row transformation. The shift row transformation is nothing but the shift row transformation is called as a shift rows. The rules for shifting rows. The first one. First row no need to shift the first row. No need to shift the first row. The second row is going to be 1 byte left shift. Third row is 2 byte left shift. Fourth row is 3 byte left shift. Like that, you can apply the left shift for shift row transformation. Finally, we'll get something. And mixed columns. The mixed column transformation is going to be called as the mixed columns, operates on each column individually. So this is predefined matrix and state array. You can multiply these two matrix, you will get one more new state array. One more new state array. This is new state array. And add round key. In the forward, add round key transformation is called as the add round key. The 128 bit of the state array bitwise XORed with the 128 bits of the round key. Then we will get the finally this is the one more state array. Then you can convert that state array into the ciphertext. This is the process of the AES algorithm and modes of operations of in the block cipher. Cryptographic algorithm works on the mainly two techniques. One is the block and stream cipher. In the stream cipher, plaintext is encrypted one bit at a time. In block cipher, plaintext is broken into the blocks of the fixed length and then bits in each of the block are encrypted together. One of the main issue with the block cipher is that they only allow you to encrypt the messages a fixed size as their block length. If plaintext, which has the block of the size 64 bits, easily encrypt. But encrypt a 65-bit message, you need to define so how second block should be encrypted. The solution for this is block cipher modes operation. The block cipher modes operation. So these are the some of the modes are there. One is the electronic code book mode, secure transmission of a single value like password and encryption key, cipher block chaining mode, general purpose block oriented transmission which is called as the authentication purpose, and cipher feedback mode. This is also used for the stream oriented. Earlier one block oriented transmission, block oriented. This is stream oriented for authentication. And output feedback mode, transmission over noisy channel satellite communication. And counter mode, block oriented transmission where application needs high speed. These are the some of the modes. And coming to the public key algorithm, so in case of symmetric key, we're using the same key for the encryption as well as the decryption. In case of public key cryptography is the method of encrypting encrypting or signing the data into the two different keys. One is the public key, another one is the private key. So we can encrypt by using the public key, we can decrypt by using the private key, and vice versa. And vice versa. So the best example for the asymmetric key cryptography is called as the public key cryptography. Asymmetric key cipher model consists of the plain text. So as we discussed the earlier, plain text encryption, public key, private key, ciphertext, again decryption. So public key is used for encryption and private key is used for decryption and vice versa. So this is the scenario. We can encrypt with the public key, decrypt with the private key. Encrypt with the private key, decrypt with the public key. And coming to the best and suitable algorithm for the asymmetric key algorithm, which is called as the public key algorithm, we can call it as the RSA algorithm. So Ron Rivest and Adi Shamir and Len Adelman have developed this algorithm. That's why it is called as the RSA. So it is a block cipher, which is a block cipher. Block cipher. This is the block cipher which converts plain text into ciphertext and vice versa at the receiver side. This is an algorithm. By using this algorithm, we can get the values. Select the two prime numbers p and q, p not equals to q, and calculate the n value p into q, and calculate the mod of n, phi of n, which is p minus 1 into q minus 1. Select e. Select e. So we can get the public key. We can get the public key. We can select the public key, which is relatively prime to the pi of n. So GCD, GCD, GCD of e comma pi of n becomes 1, and e value become 1 less than e less than pi of n. Like that we have to calculate the e value. So you can calculate the e value and calculate the d value. Once we know the e value, d equals to e to the power of minus 1 mod pi of n, or ed equals to 1 mod pi of n. So we know the e value and we can easily calculate the d value. We can easily calculate the d value. So public key is nothing but pair of e comma n. E is the public key. Private key is nothing but d comma n. D is the private key. Find out the ciphertext using the formula. So ciphertext p equals to, ciphertext c equals to p to the power of e mod n, where p is the plain text, e is the public key. And again you will get the plain text. Again we will get the plain text. Plain text p equals to c to the power of d mod n. C is the ciphertext, d is the private key, and mod n. So observe here, we are encrypting by using the public key and we are decrypting by using the private key. Vice versa you can apply. So this is called as the RSA algorithm, and we will solve one example by using this problem step by step. The first, so take p and q are the two prime numbers. 13 and 11 are the prime numbers. 13 not equals to 11, and we can calculate the n value. So it is 143, and you can calculate the pi of n value and you will get the 120. But they are not given e value. Public key is not yet given. Then we can calculate the public key. So you can apply GCD of the 13 comma 120. So this is e comma n, e comma phi of n, e comma phi of 1. So phi of n. So what happened? What is the common factor between the 13 and 120? 13. 13 and 120. 13. That's why 13 is going to be selected as the public key. We know the public key, then we can calculate the private key. So e into d mod pi of n equals to 1. So like that you can calculate. So how to find d value? So d into e 1 mod phi of n. We can convert this one by using the congruence modulo operation. So d equals to phi of n into I plus 1 by e. So this formula is going to be converted into like this. Then we can substitute I value. Then you can substitute I value. We will get some value in this case. So wherever you are getting the integer value, not decimal portion, wherever you are getting the integer value, that is called as the private key. That is called as the private key. Now, so 37, whenever you are using the I value 4, you will get the 37 directly. But in this case, 9.30. So 37. Now what happened? I know the e value. I got the e value, which is 13, which is public key. And by using that public key, I am going to calculating the private key, which is d. Finally, public key 13 comma 143, private key 37 comma 143. Then you can substitute these values into, in this case, you can convert plain text into the ciphertext. P to the power of e mod n, 13 power 13 mod 143, you will get the 52. So this is ciphertext, and you can decrypt that one. and you will get the plain text p value is plain text value is the 13. So like that you can calculate the any value. And these are the some of the problems are there. Just go through the problems so you can get easily. The first problem, p and q are the two prime numbers. Their given p value, their given p value is 7 and q value is 11, and public key, they are given public key also, they are given public key also. So no need to calculate the public key, directly you can calculate the private key. And plain text m, they are given m also. Then what will be the ciphertext values according to the RS algorithm? Just you can simply convert the plain text into the ciphertext. They are given public key and you can calculate the private key and you can convert the plain text into ciphertext. So like that, these are the some of the examples are given here. The next one is the digital signature. A digital signature is a mathematical technique used to validate the authenticity and integrity of a message or digital content. So what purpose you're using the digital signature? A digital signature is defined as a signature generated electronically from the digital computer to the ensure the identity of the sender and content of the message cannot be modified during the transmission process. The purpose of digital signature, so we're using the authentication purpose as well as the integrity purpose you're using. So the first, this is the process. The first step, you can generate key, the key generation algorithm, signing algorithm, then signature verification algorithm. These are the three important steps you're using